Now we are going to study in a similar way about the hydrogen spectra. What kind of spectra? We are going to study the emission spectra of hydrogen. And as you know, hydrogen is not a source of light, so obviously we need to heat it or we need to pass an electric discharge in order to have an emitted light, right? So what I have here is, I have a discharge tube in which I have a hydrogen and I am going to pass an electric discharge, as you can see the wires here, right? So electric discharge is passed through a hydrogen. Let us make a hydrogen also. So obviously it will emit light. So this is light, these are slits to obtain fine beam, this is prism. So what happened? The light falls on the prism and the same kind of dispersion occurs, right, and the radiation is obtained on the screen. Let's say these are the radiations which are obtained on the screen. So what we observe in this case, that like as we took an example for the sodium, where I heated the sodium, so I was getting two bright lines in the dark region, right, and corresponding to, as I told you, the definite wavelength, as in case of sodium it was 5890 and 5896 Armstrong. So what we obtain here in this case in hydrogen, when we took hydrogen sample and when we passed an electric discharge and when the dispersion happened in the radiations which are obtained on the screen, we saw that it actually you can say produced number of lines, not 2, not 3, not 5, so many lines were produced by the hydrogen. So that means it gave rise to so many bright lines, in a dark region. So obviously this spectrum is going to be discontinuous, as we have already discussed that whenever the object is not a source of light, we are heating or passing current, the spectra is the discontinuous one, and the other name for the discontinuous is the line spectra. So now the question here is, why there are so many bright lines? So this could not be explained by the electromagnetic wave theory, that why so many lines appear in this region. Like in sodium it was only 2 lines and it is just easy to study about those 2 lines. Now how come we are going to study about so numerous lines, right? So what happened actually, at that time the lines were so many that they were actually classified according to the region where they were occurring. So these lines were classified into different subcategories, that is Lyman series, Balmer series, Paschen series, Brackett series and Pfund series, right. So depending upon that in which region the lines are occurring, like Lyman series is not a one line I am talking about, it is a matter of so many lines which are occurring in the Lyman region. And which region is called as Lyman? The lines which are occurring in a region corresponding to the wavelength of the ultraviolet radiation. So those lines come under the Lyman series. And Balmer was the one which were occurring in a visible region. And Paschen, Brackett, Pfund were occurring in a infrared regions. And each series actually consists of so many numerous lines. So this is actually the hydrogen spectra. So in 1885 what happened? There was one volunteer out of it which named the visible region series after its name, that is Balmer. Balmer actually gave a successful formula in order to calculate the wavelength of any line, like in this region, it gave a formula to calculate the wavelength only in the visible region. But later we will study that formula was appropriate one, and that formula can actually used to calculate the wavelength of any radiation. But as far we are talking now at this moment when this happened, then at that time Balmer gave the formula to calculate the wavelength of radiations which were occurring in a visible region. And what was the formula? It was, I am writing here, it was 1 over lambda is equal to wave number is equal to 109677 1 over n1 square minus 1 over n2 square, right. And in this n1, because it was for Balmer series, like what we do is we classify these series into according to the n, that is the occurrence. We say that Lyman is 1, for Balmer it is 2, Paschen it is 3, for Brackett it is 4 and for Pfund it is 5. So as this formula was for only Balmer, so here the N12 is obviously going to be 2 square, because 2 is the Balmer, the number which is given to the Balmer series. So this formula was actually given in 1885 by Balmer in order to understand, or in order to know about the wavelength of the light which is occurring in a visible region. So it was called as Balmer formula also, as it was given by Balmer, and particularly for Balmer series it is called as Balmer formula. So this is all about the hydrogen spectra. So whenever you are going to get a question based on it, how you are going to attempt it? You are going to attempt in such a way that hydrogen spectra we are going to study about the emission. So as it is not itself a source, so obviously we are going to have a discontinuous spectra. So here we passed electric discharge, a slit to obtain fine beam, prism to carry on dispersion, and a screen to obtain the radiations which are obtained. And what we see, so many bright lines in a dark region, so many that we need to classify them according to the region of the occurrence. So we have Lyman, that is falling in the ultraviolet, Balmer invisible, Paschen bracket preferred in the infrared region, and as they occur we specified them with N also. And Lyman, for Lyman it is N is equal to 1, 2, 3, 4 and 5. And what is Balmer formula? It is the formula particularly given by the Balmer only in order to calculate the wavelength of the radiation that is occurring in a visible region, that is in the Balmer series. And what's that? 1 over lambda is equal to wave number is equal to 109677, that is 1 over N1 square, and here because it is for Balmer, so N for Balmer is 2, so particularly it has to be 2 square minus N2 2 square. And you will get to know more about this, because actually after the discovery of another Planck's quantum theory that we will be discussing later, actually the spectrum was made much more explanative, and you will get to know in a better way. But till this time what you need to do is you need to do an hydrogen spectra accordingly as it was explained at that time, right? So this is all about the hydrogen spectra, and we are going to see that what limitations were not explained by the electromagnetic wave theory. So just make yourself familiar with this first.